Hello everyone, welcome to the third module of research methodology course, and as a part of surprise, it's open access to everyone. The only motivation behind is to create awareness of the subject, sustainable and innovative research design. Here is a quick outline. We'll start with sustainability. Why is it even such a hype these days? Then we're going to talk about research designs and how it can fit in the concept of sustainability. I just made it up. Sustainability plus innovation. We will discuss using Terra and green buildings as examples. So what do you think? Shall we begin? If you're a researcher, you're probably working in a university, industrial R&D department, or some scientific organization, maybe an NGO or some privately held company, with primary objective to explore or to discover a phenomenon, find a solution, or to develop a product. Whatever the case is with you, you're required to develop a research plan that must be sustainable as well as innovative. We will consider here mainly research studies that are product focused, and the goal is to find a solution commonly faced by a society, for example, mitigation strategies for pollution, let's say bioremediation. This module is for both industrial as well as academic researchers, and we're going to talk at length from both perspectives. Product development phase is a very long and complicated process which might take a decade before you actually launch the product. First, you want to work on your idea. You do your search and feasibility study. And now this is a stage every one of us takes very light. How feasible it is before you do it. How many of us think how feasible it is? Very few. And this I'm going to emphasize in the sustainability part. And once you're confident, you enter the development phase, you troubleshoot it, you test it, and if it works, bingo, jump into the market and brand it. But wait, let me tell you one thing. From conception of idea to the lab to market phase, you have got to understand the impact it's going to make not only on your customers, but also the environment your customers are living in. So we start with why sustainable development goals are such a hype. From development to delivery of your idea, you need to make sure you have considered everything that is needed to make and ship your product. And you need to make sure if every step is aligned with the vision of making impact. For example, you fabricate delicate product and its packaging is way too expensive. You need to think how you're going to manage the wasted packages. Is it recyclable? And this, by the way, comes in the corporate social responsibility. If yes, if your product is recyclable, have you provided instructions to your consumers on the box or package how to discard it? Packaging of food supplies, clothing, electronic devices, if you need a shock absorber, they all are outcome of lab-based research. Sometimes you produce packaging material from food waste. Particularly for food supplies. It's a very training research and materials engineering. We are developing biodegradable plastic materials. This picture was taken at Terra. They've got a little museum where they have showcased such art pieces to help people understand the impact we are making through our habits and how science can help improve it. It's one of the beautiful pieces I've included here. So I try to help you explain this with an example. Suppose I farm bell peppers and I supply it to 5 different countries, and I need to have a packaging that prevent spoilage. So I hired someone to find me the right material to pack it. Let's say a researcher, some packaging solutions provider, soda company. They offer me an amazing option. A packaging material that not only offers a spoilage prevention but also got an integrated indicator for it. My life is now easy. I ignore the fact that packaging material is neither recyclable nor biodegradable. I don't provide consumer an insight how to discard the package. Now the problem starts here. My package ends up being thrown up as trash under CR in landfills, adding up to environmental pollution due to non-degradable and non-recyclable approach. I'm earning profit but also creating havoc at the same time for others. But that's not the case with Unilever and some larger firms who share aggressive corporate social responsibility strategies. They have introduced for a world first recycled plastic ice cream tubs with its product called Magnum. And Magnum collaborated with a supplier to develop recyclable ice cream tubs in Europe that are food grade and able to withstand freezing temperatures. This new technology uses low quality mixed plastic waste that wouldn't otherwise be recycled, says Magnum. And somewhere in China, they are collaborating with Alibaba and using AI-assisted plastic sorting machine to sort it out and proceed it for further recycling. I think an easier way is to train your consumer and you provide instruction on packaging, how to discard it, and municipal corporations, they need to develop waste management policies. Together it will make a bigger impact. And the good news is they have set up a trend of recycle and refill your Dove shampoo bottles and reuse it. In cosmetic industry, there's a plenty of plastic waste because of special plastic bottles that are required for different types of cosmetic items. Unilever says consumer behavior, infrastructure for proper recycling, and implementation of policies are a few of the challenges they encounter while trying to recover the plastic they produce. As the technology is evolving, e-waste is increasing. You will agree with me. And if you're working in electronic industry, you need to think what happens to the product once it saturates the market. How does your customer choose to discard it? What happens to the product as a whole or a part of it that you envision to develop once its life cycle is over? Your Fitbits, old smartphones, tablets, cell phones, pagers, fax machines, printers, healthcare gadgets, and the list goes on. Every year we hear news of some new model of a product or a version of something, and we are tempted to upgrade our existing gadgets, right? So what do we do with the older versions of the product? How it's discarded? Does it end up in landfills, or the company has a policy that offers you to get older product replaced by newer versions and they recycle the components? The concept of hyperconsumerism is about like your old device is not supported by new versions of software or something. It's a very aggressive strategy adopted by many mobile phone manufacturing industry. The reason why waste management and product packaging has been discussed in detail because while designing research, you need to have a futuristic approach. The impact it's going to make on coming generation since inception till the product life ends. And also a careful selection of materials, process, and applications while you're conducting research because it's going to make an environmental impact. It's a collective responsibility of government and funding agencies, corporates, and consumer to ensure that we embrace sustainable approach and embrace responsible consumption sustainable goal. For instance, as reported by Unilever, collection of recyclable packages are difficult in many countries due to consumer behavior and lack of proper waste management infrastructure in municipalities. So sorting and processing becomes challenging under such circumstances. It's a collective, again, I would emphasize, it's a collective responsibility of government-owned funding agencies, corporates, and consumers. Let's move on to the second part, which is defining sustainability. So how I define it? Look at this field, how green it is. And no matter how you intend to use it for your benefits, it should remain as it is now. What you're taking, you gotta make sure you're also returning it back. Different scholars have defined sustainability differently, and in a moment you will see definitions appearing on the slide. And I'm going to read the ones for you that I like the most. So the first one is from Brundtland. He says sustainable development means something that meets the needs of the present without compromising the ability of future generations to meet their own needs. And the third one is by Robert Gilman, who's a director at Context Institute. And I'm going to keep it precise. He says sustainability is equity over time. And the last one is my favorite one. It's by Paul Hawken. He writes in The Ecology of Commerce. Leave the world better than you found it. Take no more than you need. Try not to harm life or the environment. Make amends if you do. Sustainability is commonly understood to require the balanced pursuit of three goods: ecological health, social equity, and economic welfare. So basically, it's grounded on the ethical commitment to the well-being not only of contemporary population, but also the well-being and enhanced opportunities of future generations. So I'm going to quote here Charles Gilbert. He writes in his book, Ethics of Sustainability. And in his book, actually, he quotes David McCluskey's definition of sustainable action. McCluskey is a professor of sociology at Seattle University. And in the book, Gilbert writes, actions are sustainable if there is a balance between resources used and resources regenerated. And those regenerated resources should be as clean or cleaner at end use as it was in the beginning. The viability, integrity, and diversity of natural systems are restored and maintained in this manner. And it leads to enhanced local and regional self-reliance. This helps create and maintain a community and a culture of place where each generation preserves their legacies of future generations. In 2015, United Nations introduced 17 Sustainable Development Goals as global goals. It was a universal call to action to end poverty, protect the planet, and ensure that by 2030 all people enjoy peace and prosperity. So these are 17 goals on the slide you see over here. And the one I just highlighted, 6, 7, 12, 13, 14, 15. They all are related to environment, clean water and sanitation, responsible consumption and production, climate action, life below water, life on land. And now you will see the blue highlighted ones are social, sustainable development goals: no poverty, zero hunger, good health and well-being, quality education, gender equality, reduce inequalities, peace, justice, and strong institutions. And these are some economical sustainable development goals: decent working economic growth, industry, innovation, infrastructure, sustainable cities and communities, and lastly, partnership for the goals. Here I've included some rationale for SDGs. Increased population has caused increased consumption of natural resources. That leads to rationale 1. And unequal distribution of wealth and basic supplies is a major social concern in some underdeveloped parts of the world. Climate change, due to our heavy reliance on fossil fuels and increased urbanization, industrialization, and mining, cause loss of biodiversity. Then there is eutrophication and acidification because of excessive release of fertilizers in the clean water bodies, and high levels of carbon dioxide in the environment. This overall caused destruction of environmental amenity. And what should you know as a researcher? Ethics and innovative technology are intertwined with sustainability. We have choices as to which technologies to develop and implement. And if you remove ethics, then majority of the emerging technologies become a hazard for humans and the environment. For example, increasing use of GMOs to surplus food demand, nanotechnology, synthetic chemicals used in processes, and its management, to name a few. It is inevitable that sustainability provides developers of technology numerous challenges, from evaluating their innovations for their impacts on coming generation and ecosystem, to the adoption of alternate technology that fits in the sustainability framework. The fundamental question posed by sustainability might be of the form, like, do the benefits far outweigh any impacts on human, other species, and the environment, both immediately and over the long term? And in the latter, the questions that you can ask yourself: does my technology have a precedent in nature? Is it harmless? Does it support life in natural system? And if the answer to all these questions are positive, then you're good to go. Your technology is good to go. Laboratory of future values. That was my favorite part in Terra, and the message it conveys is very simple and inclusive of 17 SDGs. Create products and technology that create opportunities and are eco-friendly and sustainable. Whether it's a smart glass nanochip for computing devices, materials for solar cell or organ on a chip, whatever it is that you're developing in the lab, you gotta make sure the value it creates for existing and coming generations meet the Sustainable Development Goals defined by United Nations. Since the beginning of the lecture, we are emphasizing on sustainability and innovation in research design. Now let's explore what innovation literally means, and in terms of research design, how significant its implementation is. Innovation connotes something introduced for the first time, a new idea, a new process in case of research after a series of study and experimentation. Newness here is of prime importance. We often refer it as novelty. Those of you who are research graduate know its significance. Your thesis is not accepted if you have copied someone else's idea and presented as yours. There is usually a penalty on it as well. So students, in your desire to earn a degree at times, ruin the beauty of innovation in research. We see plethora of technological advancements reported daily by indexed and new international journals, and what we need to understand if it is leading us in the right direction, with the intention of which the grant was awarded initially. Sit back and ask yourself this question if you are a research-savvy professor whatsoever in your organization or academy. William Clark from Howard University, he has this amazing article titled "Crafting Usable Knowledge for Sustainable Development." But before I quote Clark's work, I would like to introduce him. He is a professor of international science, public policy, and human development at Harvard University. And his research work is focused on sustainable science and institutional participation in implementation of sustainable goals. And he writes, when scientists and engineers first venture out of the laboratory or library with the goal of linking their knowledge with action, the outcome has often been ineffectiveness and disillusionment. Wow, this is pretty strong a statement, and it must be coming from his observations, which I completely agree. He further, I'm quoting him, we highlight steps through which researchers can help build capacities for stakeholders, collaboration, social learning, knowledge governance, and researcher training. So Clark in particular emphasized on researchers' training on skills and perspective that encourage them to include sustainable development goals in the research objectives. The idea behind is to produce knowledge which, according to him, isn't only academically rigorous but also usable and realistic enough for implementation. So here is an interesting fact I want to share. Having read what Clark said, I was thinking what possibly could be the gap that encouraged him to make a strong statement regarding failure to understand and incorporate sustainable development goal in a research study. National Assessment Governing Body is an independent partisan body, and they assess national educational program in the United States of America. And if you get a chance to look at their website and browse through, you will notice how beautifully they have explained the process of inculcating a multi-dimensional approach to solve a real-world problem. And a part of problem assessment is to evaluate a student's ability to differentiate science, engineering, technology. Here I identify the gap that points back to Clark's argument on researchers' training. NAGB says the real-world problems are solved using engineering design and system thinking approach, and a common problem in institutions is that they draw clear-cut lines on who knows what, who does what, who teaches what. This restricts the thought process of students from distinct background. This is very unfortunate, but is still practiced in many parts of the world, including the one that I'm living in.
Technology is born when an engineer uses well both his scientific as well as engineering knowledge. We'll get back to this in a moment while discussing the fourth point of today's lecture.
Now this is another important slide. When a bad idea becomes an innovation. Technology becomes a hazard if you remove ethics from it, even if it is initially intended for human welfare. It can be a health hazard, environmental hazard, or even an economic hazard. Research that focused only on innovation becomes a hazard. You have to craft your research meticulously to consider all the aspects and not just to satiate your appetite to produce fancy, expensive product that stuns everyone with its feature. You may try new things no one else has tried before, and it's very innovative. For example, use of non-degradable synthetic polymers and disposable wearable technologies. Another example could be adopting highly expensive approaches in terms of processes and materials for applications like food packaging, smart sensor for routine monitoring. And a third example I would like to quote here is something like, to counter climate change, you develop highly expensive technology that only 2% of the world population can afford to have. That could be another case. The technology that you are developing using such approaches and materials or process, and you think it's innovative, but nobody can benefit from it, what's the use of such research work? Again, I would like to quote here William Clark from Harvard University. Some of that knowledge will continue to bubble up from the grassroots level through the entrepreneurship of local innovators with little or no formal research training. Some will continue to trickle down from the world's elite laboratories and universities to the work of classically trained scientists and engineers pursuing some basic blue sky research. Some is being created by researchers who have chosen to target some or all of their work on use-inspired research in support of sustainability development. And he further writes, important as these multiple sources of knowledge may be, however, they are inadequate for the task at hand. Harnessing the full potential of science and technology to promote sustainable development requires that more researchers target a significant portion of their efforts on sustainability problems, and those efforts become more effective in producing knowledge that is truly useful and used for achieving sustainability goals. Amazing, amazing thoughts.
Let's talk about research design in the context of innovation and sustainability. And we are going to explore if we can use collective approach to make a research design. And we'll close the discussion with case study using Terra and green buildings as examples of collective approach. To solve the real problems, you need to have a combined approach of engineering design and system thinking. Wasted research is generated when you focus on one and ignore the other. Academicians and higher education program evaluators, if they're not clear on how science, technology, and engineering differ from each other, the concepts of passing out grads will also remain ambiguous. As a result, you will see research work coming out from institutions which are beneficial for almost no one. Somebody who has been working on developing technology, having a collective approach, is actually the researcher working in the right direction. Crafting usable knowledge for the greater good. According to William Clark,
For the clarity, I would like to use here the definitions of each term as is stated by National Assessment Governing Board, USA. Science can be defined as the investigation of phenomena that humans observe in the natural world by using a formal approach known as scientific method to elaborate laws and principles that are universally applicable. Engineering, on the other side, is the application of these laws and principles discovered through scientific method to produce processes and tools, thus exploiting science for human needs. Technology is the combination of science and engineering to produce the artifacts of human society. And here comes the important part. While developing technology, you should focus on its socio-economic and environmental impacts. Take into account the life cycle of technology and think for a moment the benefit it offers versus the negative effect it has on its consumers and the environment they are living in. Think, how can you counter the challenges? Work on the strategy you're going to choose to adopt once the product life is over. Are you going to reuse it? Are you going to recycle it? Or you are considering some alternate technology? What drives innovation is really important. So if you are a grad, your motivation could be earning a degree. If you are early career professional, you may want to get yourself involved in some fancy research not done before. And if you are a corporate professional, you might want to have competitive edge. You want to bring this expensive, unique product into the market. But if you are a thoughtful corporate person or researcher, you might be interested in a sustainable solution to the currently facing problem you identified, a solution with equity. So I want to give you an example over here. If you are using gold nanomaterial for disposable, wearable, point-of-care technology for some healthcare monitoring purpose, and you're not sure how to reuse the nanomaterials, it will be such a waste of noble and expensive metal. So I want to emphasize here a major challenge that many tech developers tend to ignore: the technology challenge. This goes back to the first rationale of SDGs we have discussed earlier: increased population and consumption. I read somewhere an interesting thought which is worth mentioning here. I kind of forgot the source, so if it comes in my mind, I'll mention. It's sort of linked human growth and per capita consumption with technology and sustainability. This is not only understandable but also a reality. So the concept was humans should live within the current capacity of this planet. I love this part. This implies that growth control and reducing our reliance on technology that excessively use resources a part of sustainability. So incorporating sustainability in technology with increased consumption is an inevitable challenge during its deployment. And we need a futuristic approach during the tech development, and it's very much desirable to address sustainability at earlier stages. You learn from nature, right? And it has lessons for you. There is a domain called biomimetics, and it's about designing materials or processes that exhibit the properties of natural materials, for instance, degradability and renewability. This is a picture of mussels, strong wet adhesive fibers which they use to attach themselves with, hot surfaces, even if it's wet, like a stone, wood, concrete, or iron. And this is a very beautiful concept which can be used in developing technology for a myriad of applications. So one driving factor that keeps technology going or advancing is its diffusion. Tag diffusion is a term introduced by Richard Foster in 1986. So he used S-curve to help R&D managers determine the saturation point, the point at which firm needs to introduce new technology as the old tag is not profitable anymore. So you see over here, it has got different phases. In the first phase, the acceptance rate is very low for new tech. So only tech savvy people, they kind of like it, so they adopt it very fast. And then there is this tech flourishing phase, and now it's the center of all the buyers' attention. Few benefits of using S-curve are: you identify the reasons behind slow adaptation of technology. The second benefit is you can determine long lag time between discovery and application of a technology, and you can find out why it's delayed. And the third one is you know your saturation point. It's handy to keep your business running and be ready with a new tech before your old one begins to diffuse. Now, there is a constructive use of S-curve which organizations tend to ignore. Recalling S-curve is a plot of time versus market penetration. So over the time, as your penetrated market acquires your technology, you can study the positive and negative impacts of it on humans and environment, and following saturation, you can introduce something that caters socioeconomic and environmental friendliness aspects. And a good example to quote here is use of LED bulbs. It's the latest lighting technology that has replaced compact fluorescent bulbs. Later has replaced itself incandescent bulbs. And in somewhere in 1962, I forgot the exact year, LED green and red LEDs were developed for electronic purpose, and in 1993 a white LED was developed for lighting technology. So it took 50 years for LED bulbs to make an appearance in the lighting bulb market. And the best part of LED bulbs, they are long-lasting, low-energy lighting device, and the cost is affordable. So it's like 100 lumen LED consume 20 watts and has lifespan around 15 to 25 years. Based on the market research, compared to conventional 100-watt incandescent bulb that lives only for a year. So this was an example of sustainable technology. A futuristic approach is sustaination. It's a crossroad of sustainability and innovation. According to a research study, 68% of global power source is fossil fuels. Electricity generation through it causes 40% of carbon emissions. To tackle this challenge, in 2015, carbon as power source was replaced by renewable means of producing electricity. For instance, wind power and hydroelectric plants. It constitutes up to 20 to 30% of UK and European Union electricity producing source. But a major issue with the implementation of renewable technologies is its high cost. Recently, the cost has began to fall for solar panels and wind turbines. In Australia alone, a massive transition was seen between 2007 and 2017. Approximately 1.6 million households adopted a renewable power source. It was a transition from just 4,600 figure. Technological risk can be managed by deploying the ones that are humans as well as environmentally friendly. It can be done by regulations, fees, taxes, or incentives by the government. Categorically, to deal with risk associated with existing technology, you can choose to opt for alternative or appropriate technology. I've included here Terra and Singapore's green building as an example to clear the concept. The same applies to research model as well. Alternative technology refers to the ones that are based on biomimetics or used the natural phenomena in its core design. A few features of alternative technologies are recyclable, renewable, sparingly using mineral resources, and reduced carbon dioxide emissions. A few examples are PV, photovoltaic technology, wind power generators, anaerobic digesters, and biofuels. Coming to the appropriate technology, it utilizes the concept of alternative technology but also caters socioeconomic factors. It's kind of simplest alternative technology with low capital cost and same energy conservation goals. So few benefits of using green buildings over here, a good alternative for expensive DAC when combined with responsible consumption goal, because you've got your natural system, you've got plants to capture carbon dioxide and do their photosynthesis and convert it into oxygen, which you actually need. So I think it's not only a cheap strategy to deal with, but also, I shouldn't be saying cheap, it's a cost effective strategy compared to DAC. And the second one is daylight, cooler ambience due to vertical farm as an outcome of a transpiration process. So they kind of do this air conditioning thing as well. And third one is, yeah, of course, inherent carbon dioxide capture mechanism in plants, which is used in photosynthesis, we all know. Now we're going to discuss in detail the last section of this lecture. So without any waste of time, we proceed to it. Now we are going to discuss the last part and the most interesting one. I've been talking about Terra in my podcast, and I got a chance to visit it last month. It was an amazing experience, as expected. So this is an example of a sustainable innovation that made transition from lab to market despite of numerous challenges like climate factor, energy conversion efficiency, etc. It's a photovoltaic technology. And Terra is a Latin word for planet Earth, and the Sustainability Pavilion was given this name to help convey the message of living on this planet within its carrying capacity. It is one of the best thematic pavilion at Expo2020 Dubai. I've been talking about it a lot. Let's explore how this beautiful architecture fits in our today's lecture. 4 sustainable development goals were targeted during its constructions. SDG 6, clean water and sanitation. Of course, it has its own water treatment plant and net zero water. And SDG 9, innovation, industry and infrastructure. Entire building, like I said earlier, has been constructed in a unique way to meet the goals. This we explore in a moment how architecture is eco-friendly. SDG 7, affordable and clean energy, as this architecture generates its own clean energy using PVs we just saw. And PV, for those who don't know, it's a shorthand for photovoltaic. So it's kind of harvest sunlight into electricity in addition to the main canopy. You will see energy trees that not only generate its own energy but also provide shading to the visitors. So the clean energy concept has been cleverly implemented here. Sun has been very generous to Dubai, so climate factor less likely to hamper PV functioning. And then SDG 12, responsible consumption and production. And 13, climate action. Building materials used in construction targeted carbon reduction goals. So this helped them secure LEED Platinum certificate, which is for zero energy and water. I explain you first how our discussion proceeds. First, we're gonna discuss architecture and material used in its construction. Then we will look into its energy requirements and how it meets the net zero energy certification criteria. Finally, takeaways from Terra, and specifically in terms of innovative and sustainable research design. The canopy you see here is 135 meters wide, and it has got around 10,555 multifunctional solar panels. So it does not only generate electricity for Terra through sunlight, but also provide shading to the internal space, thus reducing the energy needed to keep exhibition area cool for visitors. And it does not let rainwater and daylight go wasted, and through stacking effect, it keeps the internal ambience habitable for humans. So natural lighting and natural ventilation. For a few more architectural information, I would like to share with you. It's constructed a little below the surface, which facilitates inward flow of air at night, and it kind of cools down interior and exterior of the building. Alongside, they've created a very admiring ecosystem. It has got a staple crop for food security purpose, and then aesthetic plants for soil stability, wetlands and reed beds for treatment of grey and black water, which is used for irrigation. And in the building, they've used steel, which is lightweight and 97% recyclable, to mount these PVs you see here. And to reduce the carbon footprint with concrete used in construction, they have used bubble deck slabs to construct the upper housings, which is around 10,900 meters square. Amazing, right? And it looks beautiful. Let's talk about its energy requirement. But before we go into its detail, I would like to tell you, Andrew, Wale, and Mark wrote that the project in this piece of art you see here is collective effort, but beauty you see in this picture is a work of Grimshaw Architect Company. Well, the inspiration behind a main canopy you saw in the previous slide was the raft tree. It's a drought-tolerant desert tree, and it's evergreen tree of desert. In 2008, it was declared National Tree of the Year. This is a piece of information I found from the government website of United Arab Emirates somewhere. And it has got some cultural and traditional significance. And I have found this interesting fact about it. It can withstand not only the harsh desert environment and remain green, it can live up to 120 years, more than a century. Amazing. It usually grows on low sand dunes, and its presence indicate there's water underground.
There are 18 energy trees in Terra, and they're in the shape of a tree, and they're mounted with rotating photovoltaics, which produce approximately 2.6 gigawatt hour of power per year. So this is a close-up of energy tree, and the main canopy generates its own energy like we discussed earlier, so that there is no carbon dioxide emission issues compared to conventional mode of electricity generation. And it produces 4 gigawatt hour annually, and there is a control system, sensors in the exhibition area, buried accommodation area, and they also have on-demand control ventilation system. So this overall reduces energy consumption. Daylight is delivered through a fiber optic system to the subsurface interiors they've got. And the inspiration behind is Cicada dragon tree. This is the interesting information I found. So this tree is actually found off the coast of Yemen, and it's now extinct. I would like to share few interesting facts about this tree. It can grow up to 30 feet above the ground and can live for 6 centuries. Wow. It bears berries and a 1 million sap. And look here, this beautiful dichotomous branching. So it's similar to what we saw in energy trees. Dense umbrella shaped canopy which provides shading. Few insight on operational energy and carbon aspects. So they had this inspiration of net zero energy. So the energy requirement of Terra is 226 kilowatt hour per square meter per year, and they say it can be further reduced to 180. And compared to equivalent new building, they have reduced PEUI to 42%. This is amazing. And the electricity that Terra produces, of course, renewable and clean energy. This we have already talked about. The concrete, the bubble
deck slab they used, which is also recyclable. 97% of it is recyclable, like I said earlier. So it has actually reduced carbon footprint to 41% to conventional equivalent new building. And coming to the part, the zero water target they had. So they have got this small scale water treatment plant, and it reuses water from different sources, like the water coming from a brackish surface or AC condensate, grey water or the black water. So the grey water and the black water they collected from the side and then treated over there, and it's used for irrigation purpose. And this is another amazing structure I found. They call it water tree. It was a part of net zero water aspiration. They're designed to capture rainwater, which is later treated and used as potable water. The water tree also does this dew harvesting. Now coming to the second example, green and smart buildings. And green buildings and the concept of vertical farming is actually something I would say signature buildings of Singapore. And I happened to visit Singapore Pavilion at Expo 2020 Dubai. So I'm going to share with you why I like green and smart buildings so much. First, we start discussing what are green buildings. They're self-powered, like Terra we saw. So they have their own energy generation system, and they've got green insulation. They've got a biodegradable material, for example, in paints. If you're using biodegradable paints, it will prevent release of toxic chemicals in the environment. Again, green insulation, this is by mistake, pardon me. And then you can have cool roofs as a part of green building. So they've got a specific paints and that help block the radiation and keep the internal temperature cool, or some sort of tile they are also available which help reflect light. And you can have smart appliances like dishwashers, a washing machine, a refrigeration system connected to a smart grid, so that there will be on-demand energy consumption. And a few more aspects. So this is actually a picture of Singapore Pavilion and the concept of vertical farming. So you can see how beautiful it looks. It has zero energy, of course, because the entire building is self-powered. They're using some kind of energy harvesting technology, be it a solar technology or wind turbine, and it makes you can use actually electrochromic smart glass. And the thing about electrochromic smart glass is that you can connect it with IoT's Internet of Things, and you can monitor the amount of solar radiation you want to block. You can have efficient water technology as a part of green buildings, so that you can reuse your gray water and black water for irrigation purpose or car washing. And you can also harvest rainwater, and you can treat it and use it as potable water. Round earth bricks, I really like the buildings constructed using round earth bricks. So this actually helps you give better insulation and keeping the internal temperature a little bit cooler. So it reduces the cost of your conditioning system. This is in the Hive of Nanyang Technological University, and the picture credit goes to Andrew Nelson. I also have plenty of pictures, but for some reason I couldn't retrieve it from my system, so I'm relying on the images taken by Andrew. So the architecture is Thomas Alexander. He has actually designed this architecture, and it's so beautiful. So the area it covers it like 14,000 square meter, and it was complete in 2015. The cost is around $45 million. The building is 8-story. They also call it Learning Hub, And I like the fact they call it learning hub. It's mainly because the ambience it provides you. It's very student friendly. This building is actually designed to provide a better learning environment to students, and it's not very conventional. You can see over here they don't have conventional box like classrooms and long corridors. No, they've got connected spaces, and the best part is they've got balconies and these spaces around the pods, which are beautifully decorated with plants. Seating arrangement they have in the balconies and the areas around the classrooms or the tutorial rooms. It's really cleverly planned so that every student who is actually occupying one specific place won't feel disturbed by the presence of another group of students or another student sitting close by. So this is what I like the most. So it's a marvelous innovative design for learning activities. Another interesting feature of Hive is that the concrete they have used. It's also about environmental friendly infrastructure and aesthetics. So they have used reinforced concrete to meet the environmental requirements, but at the very same time they've managed to give it this 3D texture. So this is another picture. This is the staircase picture again by Andrew Nelson. If you take a look at it, it gives you a feeling of artwork made of wet clay. So aesthetics and an environmental friendly approach at the very same time. Amazing design solution. And this is the top view from top to bottom, and you can see different towers that are centered around the atrium. So there are total 12 interconnected towers, and they are connected to this central atrium. And this kind of design I haven't seen anywhere. It's really good. It looks very beautiful. And another amazing feature of NTU is minimum of curtain wall. So you will find it mainly on the exterior, where you can see the zigzag structure, and they've covered it with silicone molds. Each room is cooled using a silent convection process. So there is no need for air conditioning system. The classrooms are interconnected and they open into shared circulation space. And it also got balconies. So you can see over here, these are the circular spaces I've been talking about. The feature that I like the most about Hive is garden balconies. It looks amazing when the weather of Singapore is really very good. And I think one reason why the temperature inside is very habitable, or I should say it's the temperature inside of the building is really very cold, not only because of the convection cooling system, but also because of the plantation and the garden balconies they have got throughout the building from top to bottom. So there are two advantages of vertical farming. Through respiration, it keeps the temperature inside the building really cool, and it also helps absorb the carbon dioxide through the process of photosynthesis, we all know. So it's sort of a way to reduce carbon emissions and at the very same time reducing the energy requirement of the building.
So, what are the key takeaways from today's lecture? Can you guess? Can you recall? Specifically in terms of innovative and sustainable research design. Okay, I'll help you. Self-reliance, responsible consumption, taking less and offering more. Lastly, making socioeconomic impact. So these are the things you're gonna consider, you should consider while working on your research study.
Going back to bad innovation, we discussed earlier, use of non-degradable synthetic polymers in disposable or wearable technologies. Now you see why it's not advisable. And the second one, we discuss adopting highly expensive approaches in terms of process and materials for applications like food packaging, smart sensor, for routine monitoring. And the third one is about countering climate change through expensive technologies that only 2% of the world population can afford to have. So these were the takeaways, and I thank you very much for listening to this lecture. We hope it will help you understand the importance of sustainable development goals and its incorporation in your research objectives. If you have got questions, please feel free to write us at inquiry@studiomac.com. We will be happy to assist you. These were the takeaways, and